Hey guys, in this video we're going to be covering Target 3C.2. Our mastery learning objective is I can solve quadratic equations involving real solutions by using the quadratic formula. So now we're going to be solving. Still have to identify our A, B, and C, and we can't do that unless our quadratic equation or our quadratic is in standard form. And the other thing to keep note of is that this says real solutions. So real solutions just means that there are no i's. Right? So real means no I. We're not going to have those imaginary numbers. Starting off with number 1, I have x squared minus 5x minus 14 equals 0. So that is already in standard form. I can go ahead and identify my A, B, and C. So A is a 1, B is a negative 5, and C is a negative 14. So please keep those signs. And the other thing is, if you don't have your calculator and you want to get it, please pause the video and grab yourself your calculator. Alright, looking at how to solve this. Well, substitute it in just like we were doing in the last video. So x is going to equal opposite of b, I'm going to put that negative 5, plus or minus square root of opposite of b squared minus 4 times a times c, and I'm going to extend that square root sign, all over 2a, which is 1. Alright, so that's the first step. The next step, I'm going to just make it in a different color so that you can see the difference. I'm going to bring down my equal sign, and I'm going to start kind of solving this. So a negative times a negative, negative 5 times a negative 5 is a positive 5, plus or minus. Alright, so plus or minus. Now, I have to draw my square root sign, but when I solve this, please do not put the square root sign in the calculator. Do not put the square root sign in the calculator. Just whatever's underneath it. So again, do not put the radical in the calculator. It's not going to work. It might work for these because these are real solutions, but in the next unit it is not going to work because we are going to get imaginary answers. So then your calculator is going to say error and you're going to waste the time of you trying to plug it in. So let's go to our calculator, and all I'm going to do is substitute, everything that's underneath it, not the actual radical, okay? So using parentheses and everything. So open parentheses, let's see, calculate, open parentheses, negative 5, close it, square it, minus 4, open parentheses, 1, close parentheses, open parentheses, negative 14. Close it, click enter. So that whole thing, everything underneath the radical, is going to be 81. So 81. Still all divided by 2 times 1, which is 2. Now, always check to see if we can take the square root of that. Can I take the square root of 81? Well, press Control X squared, 81. We should know that is a perfect square already, which is going to be equal to 9. So this is going to equal, let me kind of erase a little bit of that radical sign. Alright, so this is going to equal 5 plus or minus. We just said the square root of 81 is 9, but still all over 2. We're not done yet because all of those terms are like terms. So one of our solutions is going to be x is going to equal a 5 plus 9 over 2. 5 plus 9 is 14 over 2, which is equal to 7. But you also have to take account, right? We have to take into account that there's that subtraction sign. So we also have to subtract to get our other solution. So 5 minus 9. over 2. 5 minus 9 is a negative 4 over 2, which is equal to a negative 2. Alright, so just like we have that plus minus sign, you have to accommodate, right, for both answers. So you have the plus sign, you have the minus sign. If they're all like terms, then you have to solve for each of them. Making our final answer then, x equals 7 and x equals a negative 2. So these are my solutions. This is what x equals. Okay? Let us go ahead and move on to the next example. Oh, I could write my solutions right here. So x is going to equal then 7, and x is going to equal a negative 2. Alright. Number 2. Check to make sure that this is in standard form. X squared minus 5x plus 4. Yep, that's in standard form. Everything's over on that side, and it's equal to 0. So go ahead and answer. Identify what A, B, and C is. So identifying what A, B, and C is going to be 1, B is negative 5, and C is a positive 4. I'm going to go ahead and substitute that into my quadratic equation. So x is going to equal opposite of b plus or minus the square root of b squared minus 4 times ac all over 2a. I'm going to simplify this. So opposite, negative, and a negative is a positive 5. Plus or minus, I'm going to draw my square root sign, but again, I cannot plug that into my calculator, just everything else. So, parentheses, negative 5, close parentheses, square it. I want to subtract 4, open parentheses, type in my 1, and times c, which is 4. So that gives me a 9. Put that underneath my root sign. Still all over 2 times a, which is 2. Right? 2 times 1 is 2. And then if I check the square root of 9, square root of 9 is 3. Right? Again, square root of 9 is 3. So this is going to equal 5 plus or minus 3 all over 2. I have to accommodate for both answers. So, one option is going to be that x is equal to 5 plus 3 over 2. 5 plus 3 is 8 over 2, which is 4. The other option is x is going to equal 5 minus 3 over 2. 5 minus 3 is 2. 2 over 2 is equal to 1. So my two solutions here are x equals 4 and x equals 1. Now if I asked you, is that real or is that imaginary? We can say, well, those both do not have eyes, so we can say we have two real solutions. Right? If we had an eye, then we would have to say two imaginary. Alright, looking at number 3. Well, that's not in standard form, right? I have multiple x squareds on different sides, and I have also some constants. So what we're going to do is we're going to move the terms over to the left side. So we are going to subtract our 2x squared over, and I'm going to stack that underneath its like term, which is my x squared. I'm also going to move over that 6 by adding it over. And stack that with its like term. So my equation then, if I have x squared minus 2x, that's going to give me a negative x squared. I'm bring down my 5x because there was no other like term for that. And then I have negative 12 plus 6, which is a negative 6. Now equal to 0. From there, I can write my A, B, and C. So A is a negative 1, B is a positive 5, and C is a negative 6. I'm going to go ahead and substitute those into the quadratic equation. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative times a positive is a negative 5 plus or minus square root. Again, I'm going to check this over here on my calculator. So I'm going to do parentheses 5 squared minus 4 times a negative 1 times a negative 6. So make sure too that when you use a negative sign, you use the negative that's underneath 3. And all of that simplifies to 1. All over 2 times a negative 1, which is a negative 2. When I take the square root of a negative or a positive 1, so it's going to be 5 plus or minus square root of 1 is 1. All over negative 2. 2 solutions. So x is going to equal 5, actually negative 5, plus 1 over negative 2. Negative 5 plus 1 is a negative 4 over 2 that's negative is going to give me a positive 2. The other solution, x is going to equal negative 5 minus 1 over negative 2. Negative 5 minus 1 is a negative 6 over a negative 2, which is a positive 3. Alright, those are my 2 solutions. I do not see any i's, so therefore I'm going to have x is going to equal positive 2, x is going to equal positive 3, and those are 2 real solutions. Alright, so there are no i's. Alright, last example here. Example number 4. I have x squared minus 3x minus 5 equals negative 7x minus 7. That does not equal to 0, so I do have to move some terms over. Do the inverse operation, so I'm going to add 7x, and I'm going to stack that underneath its like term. And then I'm also going to move that negative 7 by doing the inverse, and I'm going to add 7, stack it underneath that like term. My quadratic then is going to be x squared. A negative 3x and a positive 7 is going to be a positive 4x. Negative 5 and a positive 7 is a positive 2. Now finally equal to 0. Identify my a, b, and c. A is a 1, b is a 4, and c is a 2. Go ahead and write this in my quadratic equation. So x is going to equal opposite of b plus or minus square root of b squared minus 4ac all over 2a. I'm going to simplify this. So negative times a positive is a negative 4 plus or minus. I'm going to bring down my square root sign, but I'm going to go ahead and plug in what's underneath it. So that's going to be parentheses. Oops. Move my calculator over here. So parentheses 4 squared minus 4 times 1 times 2. That's going to give me 8. That's going to give me 8. Right now, so negative 8 all over 2 times 1, which is 2. Now if we check this, the square root of 8, right? X squared, I get a decimal. So that is not a perfect square, but I can still simplify this by simplifying the radical, right? 8 is, bring over my negative 4 plus or minus. 8 can be broken down, if we find that perfect square within it, to be 8 times 2. And we can remove that perfect square, which is a 4. So, moving this on over, bring it over here. So my x is going to equal that negative 4 plus or minus. we're going to take that perfect square. When we take the square root of a 4, that is a 2. But I'm still left with whatever was still underneath there, which is my other leftover 2. All over the denominator, which is also 2. Okay? When we write these, we can't really split them up because we have a square root of 2, so there are no like terms to give us a final answer. But we can simplify the denominator. So if you see that you can find that GCF, right? Our GCF here has to be within all the numbers. So within whatever in front of the plus minus sign, whatever's in front of the square root, and whatever's in the denominator. Our GCF here is a 2. So if I were to divide all those coefficients that I just circled, our GCF then would be x equals, if I'm dividing a GCF by 2, negative 4 divided by 2 is a negative 2, plus or minus 2 divided by our GCF of a 2 is a 1. So therefore, I just have my square root of 2. And my denominator 2 over 2 is 1. So I do not need that 1 there. If you like to write the 1 here, because 2 divided by 2 is 1, but we do no longer need that denominator of a 1. So our final answer, negative 2 plus or minus square root of 2 is my answer for this question. I still don't see any imaginary answers, so it's still going to be 2 real, right? Because we're adding the square root of 2 and then subtracting. So still no imaginary answers. Okay? Go ahead and try these, and then you can go ahead and move on to the next video. Good luck.